Hello friends, I am Subodh V. Modal, professor in the Department of Mechanical Engineering at IIT Delhi. Welcome to this brief introduction to my MOOC on experimental model analysis. In this introduction, I will first define what is experimental model analysis, what are its applications and its importance, and then present the course details. Every structure or system has natural modes of vibration, which are nothing but the distinct or principal ways a structure or a system can vibrate naturally. Each natural mode is characterized by its natural frequency, mode shape and damping factor. These characteristics of natural modes are also known as modal or dynamic characteristics. Identifying these modal or dynamic characteristics is important because they determine how a structure responds to dynamic forces. Experimental analysis, also known as model testing, is a procedure of identifying these characteristics experimentally. One primary application of experimental model analysis is in avoidance of resonant vibrations of machines and structures and in troubleshooting vibration and noise problems. Another important application of experimental model analysis is in validation of finite element models. Finite element models are widely used for dynamic analysis and design. But before these models could be used with confidence, it is necessary to assess the accuracy of the predictions made by the model. This requires accurate model characteristics of the structure. Now, model testing or model analysis can be used for identifying accurate model characteristics of the structure and can be used as reference data for validation of the finite element models. The output of the experimental model analysis also forms in its own right an independent experimental mathematical model of the structure and can be used for response simulation, force identification, structural control and structural modification. The importance of the experimental model analysis can be understood from the fact that it is widely used for identifying model characteristics of various systems and structures in practice. Some examples are automobiles, airplanes, ships, submarines, machine tools, industrial equipment, civil engineering structures, consumer goods and so on. In this course, I will cover the basic concepts and fundamentals of experimental model analysis. We will start with the theoretical basis of the experimental analysis, in which we will cover the free and force vibrations of single and multi degree of freedom undamped and damped systems. Then we will look at signal processing issues in model analysis, in which we will study that how the frequency domain representation of measured signals can be obtained by digital signal processing. Then we will look at how the frequency response functions can be obtained by applying excitation on the structure and measuring the response and excitation applied to the structure. Then we will study how the modal parameters of the structure can be obtained by curve fitting of the measured FRFs. In the end, we will also briefly cover phase resonance testing, operational model analysis and some applications of experimental model analysis. The emphasis of the course will be on providing a conceptual clarity of various topics covered in the course. From my side, I will not assume any prior introductory vibration theory knowledge on the part of the students, and I will cover the necessary and relevant details in the course. This course may be of interest to masters and PhD students from mechanical, aerospace, civil, structural, automotive and naval architecture disciplines. Undergraduate students of these disciplines who are in their third and fourth year can also take this course as an elective. Practicing engineers in industries working on model testing and analysis and dealing with vibration and noise issues may also find this course interesting and useful. I look forward to your participation in this course and I welcome you all to register for this course. Thank you.